So this is a little story about quantum electrodynamics, and this goes back to my childhood. Since as a kid, I was always fascinated by sunbeams. For one reason or another, we'd always take these long road voyages or road trips here, there, and everywhere around the country, meeting relatives and so on. And it'd be in the evening, there'd be beautiful skies at sunset, there'd be sunbeams beaming through clouds, right, and hitting the ground. So I'm very much unlike this Aristotelian, I think it was, or medieval idea that there's a light source that escapes from our eyes and it goes and hits other objects and bounces back into our eyes. I never really entertained that idea. I only came across that idea much later in the history of science. Since from observing sunbeams, it's clear that sunlight in nature is just falling straight through the clouds and going nowhere near my eyes, right? That's just hitting the ground, which makes an awful lot of sense, I think, because I don't know, when it's dark, for instance, you'll be walking through a patch of woodland, and it's not like the light emitted from your eyes all the time can see everywhere. Then you enter a clearing and you see light from the moon hitting the clearing, and suddenly it's lighter again. So it always made sense to me that light was bouncing around in nature off different objects and onto different surfaces. But when I was 4 years old, seeing a sunbeam for one of the first times, I asked myself the question, why can I see it if it's heading towards the ground? And this tells you so much about quantum electrodynamics, about electrodynamics in general, about the wave patterns of light or the behavior of light, if you see what I mean. Since the implication, therefore, is that light is travelling through some sort of medium. I didn't know back then that we would call that medium the air or anything like that. Rather, it would be a kind of substance around. I suppose it would be the air, even in my imaginings back then. The important thing is that it hits the ground, so most of the light seems to be hitting the ground. Yet other light is going off in all different directions, so we can see the sunbeam. Do you see? And this connects very intimately to ideas like dark energy and so on, because you might think of light coming from a distant galaxy as being kind of like a sunbeam of a description, or several sunbeams, or billions of sunbeams, all condensed into a single tunnel of light energy pouring out of a galaxy. And yes, most of the light from a galaxy reaches us, if we're the ground, in this analogy between sunbeams and a light source, say the sun. But also, with this light coming off other galaxies, some is being scattered, some of it's going off in this direction, and this direction, and this direction, and this direction. And where is all that light going? Well, that is dark energy. That is energy that we can no longer observe directly. And all the light from a distant galaxy does not reach us, of course. Otherwise we'd be roasted to a crisp. Certainly would we not. And out in space, what's causing that then? What's causing this light to be scattered in this way? And I predict, among other people have predicted, that the light builds up between galaxy clusters to such a point that it generates radiation pressure between galaxy clusters and starts pushing them apart. And this rate at which they're being pushed apart is accelerating. There's other things contributing to the deposition of photons into those regions of intergalactic space, such as Hawking radiation and so on, that takes an electron from any surface really that we know by causal dynamical triangulations. Any atom in the universe is capable of giving off Hawking radiation. Some electrons from some atoms travel very far indeed across the universe and transport a photon to a different location. And for any given massive object, the amount of Hawking radiation that it gives off is a constant, of course. It's a constant over time. So if you have, say, a black hole, And you measure its Hawking radiation, every little bit of slice of time, however big your slice of time is. Well, say it's a second, it'll give off the same amount of Hawking radiation in 1 second as it will in another second, if you see where I'm going with this. But yeah, it's a peculiar and wonderful fact, I think. And out in space is strictly not a vacuum. That's also something of a lie of physics. It's filled with a very thin atmosphere of hydrogen and helium. So what we have is actually light bouncing between these corpuscles, these atoms, these motes of nature, if you like, these little nodes on the background, these atoms, these electrons. However, I was led in my questioning on quantum gravity to think about what lies behind that even, behind the atoms seemingly linked to atomic structure. I think the linkage of any given atom to an atomic structure is again something of an illusion, and that every time an atom in the vicinity of a hydrogen atom's nucleus changes position, which it does almost instantaneously, all the time, to a new electron each time. It's just another electron from somewhere else in the background taking its place. This leads to a different consideration, which we know anyway, I think, as well, that the universe is filled, saturated with a great many free tunneling particles, and that there's a sort of stochastic or chaotic distribution, if you like, of these negative charged particles, these electrons, underlying all of nature. Very great spooky stuff this is indeed, I think. And we see, Einstein rings around certain galaxies, these areas in which light seems to get curved around a galaxy. A particularly dense galaxy produces this effect. And is this because the material surrounding the galaxy is so dense that light is being channeled in this way around in a kind of spiral fashion between, around the galaxy? I guess it would be. And ultimately, if you were to have a closed system of two hydrogen atoms to try and measure the gravity between those two atoms, you would need to fall back on a notion of their fundamental electron density. Maybe this little cloud of, in the hydrogen atom's case, one single electron appearing, disappearing, and disappearing many different times, creating a roughly cloud-like structure around the atomic nucleus. And you have to fall back on, interactions between the electrons themselves and the nuclei, the opposed atoms, to generate this force of attraction between the two hydrogen atoms. However, this force would be cancelled out by an equal and opposite force, and that is the repulsion effects generated by the interactions between the two electrons. So, tricky, isn't it? In an all-hydrogen universe, of course stars and planets wouldn't have come together to form in the way that they do. We just happen to be lucky enough to live after an epoch of nucleosynthesis, after the Big Bang, where some lithium was formed also, along with quite a bit of helium. So we had elements heavier than hydrogen to attract the hydrogen, lighter hydrogen, to the heavier helium. Likewise, the heavier lithium to attract the heavier helium, along with the hydrogen that is already attracted. So I hope that